This presentation will cover an overview of database use cases and the role of PostgreSQL as a relational system. Databases are widely used tools in many businesses. At their most basic level, a database is a system designed to store, manage, and retrieve data. Organizations accumulate vast amounts of data, but without a structured and accessible way to store it, that data has little value. Databases address this need by enabling database administrators and other employees to organize data effectively. This organized data can then be utilized by employees, websites, mobile apps, customer relationship management tools, inventory tracking system, financial reporting systems, and many more applications. Additionally, databases are capable of scaling with a company's growth, especially with the ability of cloud-based options. As a result, they have quickly become an integral part of modern business operation. When an organization decides to implement a database, there are several important considerations to choose the best option. The first step is to determine which type of database is most suitable for the organization's needs. There are various database structures that store and organize data in different ways. Here are some examples. Columnar databases. These databases store data by columns, which allows for a fast querying of large data sets. As a result, columnar databases are ideal for data warehousing and business intelligence applications. Examples of columnar databases include Amazon Redshift and Google BigQuery. Time series databases. A time series database is designed to store data that changes over time. It collects data points with timestamps at regular intervals, making it suitable for applications that involve sensors, smart devices, stock prices, and real-time monitoring. Popular options for time series databases include TimescaleDB, an extension of PostgreSQL, and InfluxDB. Document databases. As the name suggests, document databases are designed for storing document in a semi-structured format. The type and format of these documents can vary but can be grouped together and queried based on their content. This makes document databases a good choice for contract storage and e-commerce product catalogs. Notable examples include MongoDB and Firestore by Google. Relational databases. This type of database is likely what most people think of when they envision a database. Relational databases store structured data in rows and columns and are a popular choice for tracking orders, financial transactions, inventory, and customer data. Due to their widespread use, we will explore relationship database in more detail next. Relational databases are powerful tools for many organizations, allowing for the storage of large amounts of data in tables. Each table consists of rows and columns, resembling a spreadsheet that might be created in Microsoft Excel. In a relational database, multiple tables can be created, with relationships defined based on common data elements. Key components include primary keys, foreign keys, and natural keys. Users can interact with the database using a structured query language known as SQL to perform several operations. Create, which inserts new records into the table. Read, which retrieves data from a table. Update, which modifies existing data in a table. And delete, which removes data from the table. Database users can execute queries to combine data from multiple tables, creating unique views that cater to their specific needs. For example, one table could be created to store users' addresses consisting of two columns, the username and the shipping address. Each row in this table will represent a unique username along with its corresponding address. Another table might be designed to store order data containing four columns, a unique order number, the order date, the username of the customer who placed the order, and the total dollar amount of the order. While a username appears only once in the addresses table, It may appear multiple times in the orders table if the customer has placed more than one order. The two tables are related through the common data element of the username, allowing for queries that join the tables and return a list of order numbers and shipping addresses filtered by a specific order date range. Practical application of having these two tables is that when a shipping address is stored in a user profile, it can be automatically used when the customer places an order, eliminating the need for them to enter their address each time. A database management system is software that enables users and applications to interact with data. Companies have numerous options to choose from, which some popular choices including PostgreSQL, MySQL, Oracle Database, and Microsoft SQL Server. When deciding which database management system to use, organizations should consider their specific needs. Here are some important criteria and questions to guide the decision-making process. Data storage needs. How will the data be organized? Access control features. Who should have access to the data? Do different employees require varying levels of access? Is there sensitive data that needs password protection? Backup and recovery options. How critical is continuous access to this data? Can the data be recreated if it's deleted? Performance optimization. How many users will access this database? How intense will the database queries be? PostgreSQL. It is an important open source object relational database engine. It is feature rich, highly scalable, and asset compliant. However, it may require more advanced tuning for large scale workloads, and the vendor backed enterprise support must be obtained through third parties rather than directly. MySQL, another open source database owned by Oracle, is known for its frequent security updates and compatibility with other database systems. However, it is not as feature-rich as some other options and does not provide user support. Oracle Database, also owned by Oracle, and allows for integration with cloud-based systems, handling large data sets effectively. It is recognized as a leader in database technology and offers many features built, but it can be expensive and requires up-to-date hardware. Microsoft SQL Server provides both on-site and cloud-based solutions that are compatible with Windows and Linux. It is often chosen for its compatibility with mobile devices and seamless integration with other Microsoft products. However, like Oracle Database, it is a costly option. A popular choice for many organizations, including Apple, Facebook, Spotify, and Etsy, is PostgreSQL, which we will explore in more detail. PostgreSQL was initially developed in 1986 as part of a project at the University of California, Berkeley, and it has since become widely used by millions around the world. It is an open source relational database compatible with all major operating systems. As a SQL-based system, users interact with PostgreSQL using SQL language. It is also ACID compliant, which signifies its reliability and correctness. The acronym ACID stands for A, atomicity. This means that if a database transactions involves multiple steps, all steps must either succeed or fail together. This prevents partial changes that could lead to inconsistencies. For example, when transferring money from your checking account to your savings account, it is essential that if the money is debited from your checking account, it is also added to your savings account. If one part of the transaction occurs, your overall balance may become incorrect. C. Consistency. This means that any changes made must adhere to predefined constraints. For instance, if a bank restricts overdrawing from your account, there is a constraint that your balance cannot go negative. If you attempt to withdraw an amount that will result in a negative balance, the transaction should fail. I. Isolation. Transactions must not interfere with each other, which ensures that simultaneously operations do not corrupt the database. And D, data durability. This means that once changes are made in the database, they are permanent. even in the event of a system crash. PostgreSQL is also a strong choice for organizations that require backup and recovery solutions and handle complex data types. Databases often contain sensitive or confidential information. While they have the potential to facilitate transformational data usage for organizations, widespread access also raises significant security concerns. Similar to other systems we've discussed in earlier presentations, such as email and website, PostgreSQL should be hardened to ensure data security. Here are three key recommendations. User authentication. It is essential to require user to authenticate in order to access data. Database administrators should minimize the use of the trust function, which allows universal user access. User authentication can take various forms, but the best practice includes implementing strong password using SCRAM SHA-256 cryptography, hashing, or utilizing single sign-on functionality powered by Kerberos. Altering default privilege. Administrators should modify default privilege to restrict the activities users can perform. This helps prevent unintentional or malicious changes to the data, thereby maintaining data integrity. The alter default privilege command can be used to set restriction at the user or role level. SSL encryption. Requiring SSL encryption for communication and for the data stored on the server is crucial. This can be achieved by enabling different SSL modes required. The data must be encrypted, verify-CA, data must be encrypted and verified, and verify-full, ensuring the strongest protection. Additionally, it is important to encrypt data at rest using Linux disk encryption or third-party PostgreSQL TDE solutions, along with SSL TLS for encryption data in transit. These recommendations establish a solid foundation for ensuring that database access, visibility, and modifications are restricted to the appropriate individuals. This concludes the presentation on database. Sources used for the information in this presentation are listed here.